Okay, for today's lesson, you are going to need a graphing calculator. You're going to need at least 3 colored pencils, and you will need this sheet. So the first thing that you need to do is pause the video, and you need to write down, I've left a big open space for you, all of these definitions. There are things we've already talked about, but we're going to write them down again just so that we can help recall them. Okay, now that we have those written down, let's look at example 1. So we're going to use the equations y equals 3x squared, y equals x squared, and y equals 1/2 x squared to answer the questions. Okay, so just as in lines, parabolas are going to have a parent function. So with lines, we said the most basic we could be was just y equals x. With quadratics, it's going to be very similar. Y equals x squared, there's nothing being multiplied by x squared, there's nothing being added at the end. This is just as basic as you can get and have an x squared. So this is our parent function. So we're going to look at what happens as some of these numbers change. So I'm going to go ahead and label red, green, and blue. Okay, so I want you to answer these questions on your own. Tell me which coefficient from standard form, which as you wrote down earlier is ax squared plus bx plus c, which one changes every time? Well, I don't have plus bx plus c on any of these, so that leaves me with just a. Okay. And so let's graph these. So I'm going to pull up my calculator. Turn it on. All right, so let's go to y equals. Clear out everything that's in there. All right, my first equation is y equals 3x squared, so 3. Remember, x is this button right beside alpha. And I can use this squared right here, 3x squared. All right, I'm going to come down to my second equation now. It's just plain x squared. So x squared, that's really simple. And last, I do have a fraction. So remember, we want to get in the habit of just always putting parentheses around our fractions. Y equals 1/2 x squared. So remember, my calculator is going to graph these in the order. So even though I'm graphing 3, I can tell which one's which because this one will be the first one graphed, the second one, the third one graphed. All right, let's look at them. So there's 3x squared, x squared, 1/2 x squared. And let's just do a simple trace over onto our graph. So I see that 3x squared was the one that was inside the most. I see that x squared was the center one. And then I see that 1/2 x squared was the widest one. If I wanted to graph these precisely, remember, I could go to the table and I can look up y1, y2, and y3, and I could have gotten specific points to plot on here. Okay, back to the graph. So I've got this. So let's look at this. So my first question is, what happened when a was greater than 1? Well, let's look up here. 3 is the only number that's greater than 1. And it looks like this one it looks like it's the skinniest, doesn't it? Okay. When a is in between 0 and 1. So the kind of numbers that are between 0 and 1, we know are fractions. So whenever I had a fraction, it looks like this was the widest one. Now I want you to, in your mind for a second, imagine a stack of Play-Doh. If I had a ball of Play-Doh and I were to pull it this way, I would be making it taller. I think we would all agree. By default from that, what else would happen to the Play-Doh? It would get skinnier. Okay. Same if I had that ball of Play-Doh and I were to smash it down. If I were to smash it, the Play-Doh would need somewhere to go, so what would happen? It would expand. So actually, what is happening in these cases is that although it looks like A is getting skinnier, what's really happening is, or the graph is getting taller. And then the same for this. Although it looks like it's getting wider, it is, but it's not necessarily because the graph is getting wider. It's happening as a result of the graph getting shorter. So the graph is getting shorter. So here is our vocabulary for it. If a is greater than 1, we call it a vertical stretch. And if a is a fraction, we call it a vertical shrink. So make sure you get those two definitions down.